Good morning, everyone. Today, we are going to focus on one specific kind of time complexity. It is linear time complexity. It is one of the most common and easiest to understand. At first, we have to understand what does linear mean in everyday life. So, if something is linear, it means it grows in a straight line. For example, if you buy one apple, you pay 1 rupees. If you buy 2 apples, you pay 2 rupees. And if you buy 10 apples, you pay 10 rupees. So the total cost is proportional to the number of apples. That is linear. Double the apples, double the cost. So linear is proportional to input size to input size n. So in computer science, when we say an algorithm runs in linear time, we mean that if the input gets bigger, the time it takes grows up in the same proportion. If you give it twice as much data, it will take about twice as long. Let's take some real world analogies. Imagine you have a book with n pages and you want to read the whole book from start to finish. So if the book has 100 pages, you read 100 pages. And if it has 200 pages, you read 200 pages. So the time it takes is proportional to the number of pages. That is linear time, and we defined it as a order of n. Now what if you only read the first page? Then it does not matter how many pages the book has. You always read just one page. That would be the constant time, order of 1. But if you must read every page, it's linear. Let's take another example. Suppose you have an array of n numbers and you want to find their total sum. How many operations does this loop do? It goes through each element exactly once. For n equal to 5, it does 5 additions. And for n equal to 100, it does 100 additions. So the number of additions is exactly n. This is a perfect example of linear time. We say this algorithm is theta of n because it is always n steps no matter what. If you double the array size, you double the work. So this graph is a perfect example of linear time. I have another classic example of linear search. Suppose you have a list of names and you are looking for a specific name like Aryan. So you check each name one by one until you find it. So the best case, when Aryan is the first name, you find it in one check, and that's constant time, omega of 1. And for the worst case, when Aryan is the last name, you check all n names, that's n checks, order of n. So what is the average case? So average case, if the name is somewhere in the middle, we check about n by 2 times, but still proportional to n. So even though the best case is fast, we usually care about the worst case because we want a guarantee. And in the worst case, the linear search is order of n. Notice here, the linear search does not always do n steps. Sometimes it does fewer, but the worst case growth is linear. That is why we use big O to say it will never take more than n steps. So now we have to understand why linear time matters. So linear time is often the best we can hope for when we have to look at every piece of data. If you need to find the average of all numbers in a list, you must look at each number at least once. So it's at least linear. So now, how can you tell if an algorithm is linear? Look, for a single loop that goes through all the input and inside the loop you do constant time operations, or no nested loops that also depend on n. Even if you have two loops one after another, it is still order of n because 2n is still proportional to n. But if you have a loop inside a loop, that is order of n square. Let's recap what we have learned today. So the linear times means the time grows proportionally with input size n, and we write order of n as the worst case, or sometimes theta of n if it is always n. Linear time is often the minimum required to process all input. Now I have two questions for you. These are very easy questions. Just try to give the answers. So our first question is, if an algorithm takes 1 second for 100 items, how long might it take for 200 items? If it is linear. So simply the answer would be 2 seconds. Now let's look at the second question. It says, is looking up a word in a dictionary by reading every page linear or constant? So it is linear. If you read all pages, but if it is sorted and you use binary search, it is logarithm. So we will cover that later. So great. Now you understand linear time complexity. Next time we will look at other common complexities. Thanks for watching.